This is the Amp Hour Podcast. Released May 13th, 2025. Episode 693. Small Scale Electronics Manufacturing with Colin O'Flynn. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Colin O'Flynn of Dalhousie University and also New A Technology.
Welcome back, Colin, for the third time. It's been
thank you.
Yeah, we're on like a five-year cadence here. You and I chat a little bit more often than that, but it's good to have you back.
A recorded 5-year conversation. That's key.
Yeah. Well, if we just keep this up, then it's like a little time capsule for each year we operate, right?
Time capsule for AI, right? To be able to better recreate
right. Yeah.
Our history, our future.
Chris and Colin sound progressively older every 5 years,
Yeah.
Both in temperament and in vocal tambulations.
Yeah. Complaining about more basic things.
Yeah, right. Don't you hate soup? Oh, soup. I guess we'd like more soup. Anyways, how you been? So you're kind of back in academia a little bit more, huh? You've I think the past two times. Well, let's see. We have you on episode 239, and we'll obviously link these in. And that was in 2015, and then 552, which is 2021. And I guess you were just starting at Dalhousie in 2021, right? That's like when you just started there.
Yeah. So, and actually, it's kind of there's a story in there too, because in between I was not at the university for a couple years. I had started back at the university, and then when Chip Whisperer and New AE was sort of taking off, I ended up leaving. Also over the pandemic, things were a lot trickier to teach, so it felt like I needed to dedicate full time. Which at the time, it's often you're deciding. At the time, it felt like, okay, that's the end of academia. But I came back.
Is it like an in or out kind of thing usually too? I mean, like I guess I don't really know. Like, was it hard to switch in and out like that?
It depends. So I kind of got lucky with the timing that they were growing the computer engineering program. So this program didn't exist the first time. The first time I was actually connected more to like an entrepreneurship program. And they were growing computer engineering with the company. I was still able to publish. So I was still publishing. That's normally the problem, right? Is you go to industry, you don't have as much time for publishing, and you're kind of left behind. So it becomes harder to come back. But they promised me this time I can't leave and come back. They said there's a limit to how many times you do that.
Right. They told me that too, but it was more in an academic probationary regard.
Yeah,
Chris, if you don't get those grades up, you can't come back. Everybody gets one. Well, that's cool. So what is it? What are you publishing about these days?
So it's basically continuing on with right now side channel analysis with some of my more recent work. Which was previous work too, but especially looking at side channel over different ports. So one more interesting thing was like using jitter measurements. So as data flows through devices, the time delay varies with voltage, which means you can actually get a really accurate measurement of power on a device, which then gives you information about secrets. And so what I did is I ran that through the JTAG port, because, JTAG, which is funny because this is the oldest attack. Like, right, Joe Grant's been doing JTAGulator for years.
Yeah, right.
Everyone thinks JTAG is locked down. But yeah, if you run it in like a boundary scan mode, right, and you just do bypass, where it's just shifting bits through, you can basically shift through bits at pretty high, like sometimes a few hundred megahertz, and it basically gives you a pretty good scope. Yeah. Which is,
and then
cool.
What is the differential, like, what's the jitter amount? Is it like nanoseconds, picoseconds that you need to be able to detect?
It's pretty small, although the thing is that I did another version of the attack where what I do is it's called like fault sensitivity, but I basically clock in a bit right at the clock edge, right? And so depending on how that clock edge shifts, it's going to see a 1 or a 0. And so you actually only get 1 bit of output data, did it clock in a 1 or 0. So it's kind of like 1-bit GPS receivers type thing. The SNR is worse, but you get enough data and still works. So
averages over time sort of thing, or
yeah, exactly. So there's a lot of pretty interesting stuff you can do with that.
Do you need then like a super specialized scope? Is it like a scope on top of something like the Chip Whisperer, or like what is the measurement methodology for doing that sort of thing then?
Yeah, so for this one, it was actually just a old school, but RF mixer. So they also give you phase information as well as frequency if you mix the two signals together. So basically, that's what was used, is just a little cheap mixer. So all the designs are available if someone wants to run it. And then I added it in FPGA code to the Chip Whisperer.
Yeah, that's great. And then can you maybe run people down again? Every 5 years is good, about like kind of how a side channel generally works in a broad scenario.
Yeah, I think I kind of dove into it. I don't know if this is the right intro, right? But I should have started with what is side channel. I feel like more people know it now, but basically the idea is that you have information that influences some measurement you could do on the device, which by that I mean specifically we're often looking at power analysis, which is, as a device is running, different instructions take different amounts of power. So if your code does like a load or an add or something, this will look different in a power trace. And it even gets more interesting, which is depending on the data transferred, it can vary a bit as well. So the if you set a bunch of ones over a data bus, it takes more power out of a positive rail than if you send a bunch of zeros, which seems kind of crazy that it's, that you can actually measure that. I almost didn't believe it at first when someone said that. And then I was like, okay, let's test this. But yeah, it actually works because it's charging, right? The bus internally is basically capacitance. And so you're charging a capacitor to set it to high, or, discharging to set it to low. And that comes from different power rails. So if you measure on one, you do see this.
And I remember, so I got to go to a training that Colin ran as well. And I remember sitting there and kind of like watching what looked like a scope trace on like a 3.3 volt rail. And then you saw, it was kind of like floating on top of that rail. You saw like action happening, whatever. And then eventually though, you were using that to pull out encryption keys, which was kind of the wacky thing to me. Like you were doing kind of cross-referencing based on different actions that were happening. I don't remember the exact part of that, but that's what's in my mind at least.
Yeah, no, I mean, that's basically, a high level what happens. The idea is, right, in that power trace, if I know at what point in time, for example, it's loaded an encryption key and it XORs that encryption key with some input data, I know the input data because it's not secret. Like that would be the, data coming in over the air, for example. I don't know the encryption key, but if I can use the power trace to say, hey, there's, it looks like there's more ones at this time after it did the XOR, or less ones. So we have this linear relationship. You could say, well, I know I put in, for example, 0. So there's 0, 1. So all those ones came from the key. Right. Okay. So by varying what the input data is, you can imagine that you could sort of slowly puzzle out in a way, right, what the key is, because it's like, well, if I know I put in this and I see a lot of ones or low ones, and the only thing that's fixed is that key, then I can kind of figure out what it is.
I'm still not sure I quite remember. I remember XOR, but so basically, though, it's kind of probing with known inputs, unknown kind of reference data, and then known outputs because you're measuring it. So that's kind of the idea. Is you're back calculating that key. That's kind of the idea.
Yeah, exactly. So that's the thing. You basically have, and this works because you have like the algorithms, they were not secret. So you can build a pretty accurate system model. So the part that's kind of crazy is that if you do a test where all you do is you put different data on the data bus internally and measure the power at that point in time, it's it's like a shockingly linear relationship. I was, I'm always amazed when I do this demo and it's like, this sounds like a simple. Yeah.
So much to protect against this, huh? I mean, and that's the other thing too that's interesting is like I remember seeing some marketing material that maybe even referenced the Chip Whisperer, but it was like from chip companies. Now chip companies are like looking at it, they're like, oh, we should fix this, and we have countermeasures to try and make it better. But it, like you said, it's physics at the end of the day. It's like capacitance and charge.
Yeah,
and all
exactly.
That stuff, right?
But I mean, and there's a lot of ways to fix it. So they can, more complicated in the hardware. You can do dual rail and things where you basically have two different lines swinging high and low. So if you had a differential, right, the there's still a tiny bit of a glitch when it switches, but it's much, much, much more difficult to detect. You can also change the algorithms a bit, like still using AES, but you can imagine, right, if I XORed in random data every time, and the algorithm is designed such that I can XOR that data at the end to remove the effect of it, like I've complicated the attacker's life because they no longer know what's happening internally.
Got it. Yeah.
But I mean, the bigger thing, because this often comes up, and people say, "Oh, okay, what should I do? Should I use super advanced crypto right to avoid this?" But it's like, it doesn't matter. The best choice, because as we might talk about later too, there's a million different attacks, and if you have one key for your 10 million devices out there, right? Like that's
right. That's the problem for sure. Yeah. Right.
Exactly. Like that's the problem. If someone does a crazy power analysis attack and recovers the key from one device, like you shouldn't care.
And that controls your whole fleet of devices. That's
right. Like
that's
you've made a bad decision early on, and you're just trying to fix it through something else.
Right. Okay. So, and you mentioned the power rails. You mentioned JTAG. Are there other like interesting, like I guess you kind of have power in a couple places. You might have the battery. You might have the USB port, the 5 volts in the USB. Are there other like ports and other ways to do this sort of thing?
Yeah, I mean, and that's kind of the interesting thing is that so with this one doing this phase modulation stuff, it was kind of showing digital ports in general. So JTAG is one of the more accessible, but the other one I didn't implement it, but sort of looked at was like an SD card or SDIO interface, because that often is user, right? Like some front panel interface has
push something in there, right? Yeah,
exactly. And and they're it's high speed, which is good for being able to sample a lot of data. So any of those interfaces,
is it usually encrypted through there, or would that not even matter?
It wouldn't, because like really what you're doing is you're basically using, for the attack to work, what you want is a clock, ideally that comes out from the target device, because that clock has small phase shifts encoded in it.
Okay.
Right. So if you get a clock, and like the SDIO is good because it has a clock, right, that runs quite a bit.
Got it.
And you can kind of trick the system because you can send busy states back. So like if it does a read, you say, "Oh, actually I'm busy, please continue to read for me." And it'll just keep basically giving you a nice clock, and every clock edge has some data encoded that may do that. And then, there's a similar thing. And one of the interesting things about, I don't know, one of the points of this paper actually that I had tried to make was not that, this is a cool attack, but it was actually referenced in some of the earliest work. Some people explored it and then sort of put it away. So like a lot of things in life, right, it's sort of been sitting there, from like 2003, I think the first paper I saw referencing this sort of angle modulation, they called it. Yeah. So
does it mean that there's also like other clocked things that you could target, like displays and even like RF front ends and stuff like that?
Exactly. And that's kind of the idea is, and after I'd worked on this paper, someone else totally independently published, basically using the phase modulation. They were measuring over RF, the phase modulation. They were showing that has the advantage, of course, you can, you get longer distances, which was a bit of a spin-off of someone else had previously shown that you could do this over just RF. What they actually did is they used I think it was a 802.15.4 chip. But the idea is, right, as that chip is transmitting, you have it's running crypto at the same time. And like this ends up modulating onto the RF carrier.
Oh, really? That's pretty wild.
It's like kind of one, I think most of them are one die, right? And so you're going to vary. And
depends
even if not,
on the chip. Like I think the TI one has a dual radio, like two like chiplets or something like that.
Okay,
but I think the Nordic one is like single die, like the 5240.
And even if it's chiplets, I think there's enough coupling was the thing, because like most of the radios are designed so all they care about is am I going to meet EM requirements? Right. So like if they see a little bit of spread because of CPU noise, they're going to say, yeah, that's fine. I don't care about that. Someone comes along to attack it and they say, well, that phase spread is actually related to data being processed on the CPU at the same time. And which someone showed that quite a while ago. And there's been, as I said, some follow on that. And then this kind of phase modulation over RF was proving that as well.
Yeah, it sounds like you get to buy some fun toys then that also, I guess you mentioned some of it's simple toys, but I mean, when it starts getting into the RF space, I'd imagine that starts moving you up the purchase list of all the fancy RF measurement equipment places.
Well, I'm lucky there, though. Actually, I sort of co-located with a professor at Dalhousie that does tons of RF, right? So he has like a 40 gigahertz spectrum analyzer.
The good stuff. Yeah,
exactly. Right. Like anechoic chamber. So half of what I'm doing is trying to think, okay, well, we have access to this. Like, let's make sure we use it for for doing this stuff. So, which actually this work wasn't, but yeah, exactly. I really want to. That's like the next stuff I want to look at is a little more on EM, like medium long range, which I think is super interesting.
Yeah, I mean, it's interesting. Looking at the stuff you've been doing, I feel like I keep coming across it in my work where I'm like, oh, this is what Colin was talking about. Like, as I get more into the space and just think more things that need to be encrypted, more, putting secure elements onto things, all the trust zone stuff, like things that I know that you've played with, you've tested and stuff in the past. And it's like, oh, this is why it's here. So it's good to have, just to also contextualize for people that are like listening. They're like, well, why do I care about security? It's like, well, maybe you don't right now, but at some point you might, like.
Yeah, it's going to come. That's the thing.
I mean, broad strokes across the industry, are things steady state? Are they improving? Are they, are we seeing more focus on this, less focus? Doesn't really matter. I don't know, like where the state of the hardware security industry is.
Yeah, I mean, there's definitely more focus on, especially, the thing I find interesting is when I sort of started this, I don't know, like public chips that talked about side channel fault injection resistance were super low. There's one or two vaguely mentioning it, but now like the Raspberry Pi, that new device, the 2350.
Oh, 2350. Yeah.
Right. Like that, they went really far out of their way to add a bunch of more fault injection, but countermeasures and even just tools that, you can use as a developer. When
they were on the show too, they were also promoting how they ran the contests and they were trying to get people to test it and push the limits of it. Like that security focus was definitely a thing they wanted to talk about, right?
Yeah, and that would be like was unheard of. I mean, they really pushed it harder than anyone did. But there's a few others. So like we've been involved a bit with the Open Titan project, which was an open source root of trust that Google was heavily involved with, and is basically going to be using that as part of their some shipping hardware. So there's some blog posts or PR where they talk about where they're going to end up shipping it. But yeah, so like there's been a big push, right, for not just security, but like actually having more transparent security, I think is the thing that is more helpful, right, for everyone.
Yeah, so like traditionally it was like, well, no one's going to find out about this because like how would they possibly get information? And now it's like I ask a GPT to give me all the information. It's like, here you go, sir.
Yeah. No, very true, right? Like,
yeah. Can you remind me and the audience about like root of trust? I remember Laura from Laura Abbott was on the show. She's at that server company that I always forget the name of.
Is it Oxide? And they were also working.
Yeah, Oxide. Okay. Yep.
I was like, that seems like the only cool server company. I don't know who else you have.
Pretty much them and Ampere.
Okay, yeah, okay. I take it back. Yeah. I'm sorry, Ampere.
Yeah. Those two together though. Yeah. Those and then like what, Dell?
Yeah. Right.
Oh, so cool, dude! You're getting a Dell.
I'm sure they're doing cool stuff, right?
I'm sure they are, but it's just like they're stalwart in the industry.
It doesn't have it doesn't have the same right cool startup feel.
Dell might have a podcast, but is it as good? I don't know.
Yeah, well, you just wait.
So could you remind people how the root of trust stuff fits in as well? Because that's like a security element that's on the server board. Is that right?
Yeah. So it can be on anything. I mean, the idea of the root of trust is this is what's booting your system, right? Okay. So the normal use case for it, and I'm going to kind of generalize because someone's going to definitely be like, that's not actually true. I don't actually know all the industry definitions.
Don't worry, Colin's just explaining it for me. I'm a dummy. Just hand wave
I have to have that. See, this is one of the downsides. I don't know if it's feels like you're complaining as a hipster now. But now that there's more people involved, before you could totally get away with like
it was totally cool before. Yeah.
Yeah, being like more vague or being a bit wrong because no one knew, but now lots of people know. So it's like, oh, anyway, but yeah, so the root of trust, the idea is this is booting your system. So you have an untrusted system. How do you boot it up? And so the idea is you have this one super secure device that's like checking every stage of the firmware. So devices will have this internally, right? So some devices will say, they have the first stage bootloader is in ROM and normally can never be changed, right? And then that boots some external bootloader that boots the next one. So it's like bootstrapping your whole system securely. It normally also can then handle stuff in the future, like if you need to sign something or you're getting a firmware update, right? The root of trust is going to manage that and make sure you don't, get a bad firmware update or malicious, really, not just bad.
Right. So is it the idea is me as a user, I log into a server built by Google, whatever, there are multiple layers of software on top of it, whatever. And I'm trying to say, how do I know this is actually the server it is? And I could keep diving down. And then at some point, this is the chip that says it. Is that kind of the idea?
Exactly. Yes. This is your like total, right? This is your root of trust. This is how you trust everything. And like the idea of OpenTitan was they had kind of said, well, look, how do you trust the root of trust? Right? Who says that?
Who watches the Watchmen, right?
Exactly. And this was also around like the Snowden time. I think they were starting this project. So it was a real question. Like, what if the government forces Google to tamper with your server? Google wants you to believe that they have no tampering. So they kind of said like, well, if it's an open source chip, then you can in theory do, attestation that the design is what's running. There's some tricky bits in there, but the general idea, right, gets you all the way up. But I mean, and people use them like for little, Chromebooks, phones have these, like,
got it. Yeah.
Kind of everything will use this.
And so it's just there it's got all this stuff to prove itself out. I'm looking at a data sheet, which Colin also is seeing my screen. So at least we can have a shared context here, but it has a lot of stuff in it that I don't know why it would need it, but I guess random number generator, okay, key manager, sure, like power monitoring, like it's just able to like look internally and say everything's cool, boss. That's kind of the idea.
Yeah, right. So the thing is they and you have to remember too, they're pretty somewhat generic, but they're often booting stuff, so like they might need to read from an external spy and validate it, and then they can emulate that spy to a system, so that someone doesn't do like a attack where they switch, right, what the spy image is. There's the classic sort of attack where the system looks, right, that validates some firmware image and says, okay, that firmware image looks good. So that's when it does the time of check. And then when it goes to use it, it like reloads the spy flash because it doesn't have everything in memory. It didn't have enough space in memory. And the attacker switches it at that moment in time.
I see. So, right. It's like the sleight of hand, but with memory.
Exactly. So like that was a common. I mean, it's less. More people are doing validation for the whole thing, avoiding that, but it's still an issue. So if you have a root of trust, right, it's actually forcing that. Like there's nowhere to switch it, because if you switch it, the root of trust is going to see that, or possibly not even read it. It might just cache everything.
I guess, Laura was on the show, and prior to that, I think I maybe heard it one or two times, but I just didn't really understand it. I think the only thing I had heard about it under was the when there was like that scare about there being a chip on one of the servers, and then I remember Joe Fitz made that tiny sticker with like the little pencil tip. I want to believe, or whatever. I don't remember what it was. It was like someone had apparently found a malicious chip on a server PCB, right?
That was which, and I don't even know. And I think the chip they used
was like unvalidated, right? It was like a lot of fear mongering and that sort of thing.
Yeah. Right? Well, and I remember the big thing was the chip they used in the photo was I think it was just like a ball-in or something, right? It was like totally. And I don't know if that's what they were saying was malicious, or they were just like, here's a cool looking chip. Let's put that on the tip.
Right.
Like, you never know with this.
To a journalist, it's just a black blob on a board sort of thing.
Yeah, exactly. So but yeah.
Okay. How did we get here talking about the OpenTitan and the root of trust? I don't remember.
The state of the industry.
State of the industry.
Industry's
Yeah.
looking better, I think, is the summary.
Okay. So there's just more focus on it, it sounds like, and it's like there's more people out
more
there
focus.
thinking,
and I think personally, right, like I think a lot of people though think the open solution is good. Which I think is nice. Like, as I said, the Raspberry Pi, seeing what they did is really cool. Seeing stuff like Open Titan and there's sort of different levels, but it's not just that there's, venture capitalists saying, let's make another proprietary solution for AI does XYZ, right? It's like, here's an actual thing that could actually help people, seems reasonably secure.
One thing that you always kind of bring up is like these attack vectors and like how people think about it, but how should people listening think about it for their own products as well, of like, oh, this is what someone is likely to do. And then I guess what something I always think about is like, oh, well, they need to have physical access sometimes, but not always, so like the likelihood of certain things. Is there like a good guideline for that sort of thing? So if I'm designing a product, what do I have to care about? Because there's no like test other than like maybe hiring a security firm, because they're just general guidelines.
Yeah, and there is, and to be honest, and this is where I'm bad again, this is where people listening will know and correct me, because there is some more recent industry guidelines that I've seen released. I haven't even read them yet.
Oh, yeah?
Okay. But, to go back to an older one, like ARM had their PSA platform security architecture, right? Which was a level, and they basically had several levels of, if you want to get your device secure, here's like what you can do. So the highest level involved actual side channel and fault injection testing. I liked this one because the lower levels were just kind of checklists. Like, so you could do it yourself. You might have to pay money to get an actual PSA. I don't actually know what the system is for commercial, but they did have a bunch of stuff you could download that would say, hey, and it would be reasonable things. I liked it because it would be like, okay, is the JTAG port locked, unlocked, right? Like things that people actually mess up all the time.
Right. Totally.
So you could get like a different, and they had a few example threat models where it's like, okay, here's, if you're making a smart meter, I think was one. And
yeah, there was one. I'm looking at this page right now. It says smart meter, asset tracker, network camera.
Okay, yeah.
TMSAs, right?
Yeah, threat model and security analysis documents, I think. So that's kind of showing you, okay, if you have this doc, here's, and it goes over like, okay, well, would people have physical access to it or not, or stuff like that. So
not lost on me that I'm downloading a binary from a thing about like threat models. Oh, yeah, open this Excel file on your computer. No big deal.
Macro enabled, of course. Why would it not?
Right. Yeah. And then that's how I got hacked by VBA.
Yeah.
Yeah. I mean, yeah, they definitely give you some stuff here, and I'm sure they would definitely take your money if you wanted to pay them to certify it, right?
Yeah, but I mean, there is, as I said, I've seen some other, like there's some, I think the UK government just released a kind of IoT smart device guidelines as well. There's been a few kind of like that, and they're pretty, again, like I think the cool thing we're seeing is that things are reasonable, I want to say, right?
Yeah.
They're looking at real threats and
I know there's some like upcoming regulations in the EU. CRA, I think, is the one in the EU. That's like a requirement for like being able to OTA stuff. And then there's Trustmark or something like that in the US, but which is less of there's like some kind of marking as well. But I don't know, whenever they think about these things too, they're always like, oh, you're running like a Linux box and you left SSH open, and like
yeah, which is why the ARM PSA one I like, because it's, again, this is more like embedded, right? That's their whole thing. So
yeah, I think it
is. If you're doing embedded, like it's a good, as I said, at least at level 1 or 2, it's like a checklist you can do. I think you can even just certify without paying from,
Got it.
My information is years old, not fact checked whatsoever, but.
Well, this is the AMP hour, so you don't have to worry about fact checking.
Perfect. Okay, I like it.
It's not a thing we do here. Don't worry about us. I don't know. I did have a consulting thing back in my day of like, I had a third party come in and like do like an audit, but like all the things they were doing, there was just like, oh, are you not like a Raspberry Pi? I was like, no. Okay, then we don't know what to do with you. Okay, then. That's less useful, I think the thing is, like, as like a product designer, it's like I want to know the best practices, so things like this are good, I feel like. So What about the embedded side of things? So, I mean, like, are you focusing mostly in the embedded space and lower? I mean, like, are you doing that kind of stuff these days?
Yeah, that's I mean, my own background is less like Linux high level. So
Mm-hmm.
most of the stuff is, lower level bare metal embedded, looking at that.
Mm-hmm.
Um,
Yeah.
yeah, little architecture stuff. So I mean, one newer thing I've worked on is, and I haven't worked on it so much. I worked on board designs and have been involved in it. So I feel like when I say worked on, I don't want to have any credit. Is this Chariot system? And in particular, so designed this board Sonata, which Low Risk, New parent company, had a project where they made this open source. Effectively, the idea is to have like an open source microcontroller kind of soft core device, right? That just feels like a microcontroller, but it's running something called Cherry, and Cherry for IoT, which does all this compartmentalization. So it, rather than just saying, are you in, like, if people are familiar with Cortex M33 and these devices, they have like a secure and a non-secure mode, and, different peripherals, you can say, okay, the spy device can only be accessed by the secure code.
Yeah.
And so Chariot's kind of cool because you define compartments and you say, okay, the spy driver code can access the spy peripheral, and that's it.
Huh. Okay.
You are, and so it's like at a much more fine grained level. So it's kind of cool because you can say, like, okay, the web server process can only access these certain things and like this API, stuff like that, right? So if someone hacks it, it's like there's just no, there's no way to read other memory. Yeah.
Right.
And it solves the problem. What I see with Cortex M33 or any of these where it's just secure or non-secure, as a time crunched embedded developer, what do you end up doing? You put too much in secure because you're like, I need access to everything. Okay, secure code.
There's no one really enforcing it, right? It's just like you're only really size limited based on how it's laid out, I think.
No, yeah, I don't think there's really it's up to you to decide what's secure and what's non-secure, right? So you're supposed to go through and make sure the secure code is only the finest quality code that has no problems ever.
That's how I get around it, by never ever having fine quality code for my stuff.
Yeah, exactly. Perfect.
Yeah.
Or just do open source. It doesn't matter.
Yeah, right. Yeah, someone will check it at some point on GitHub, I'm sure.
Perfect.
So this board looks like it's had a 40-pin header. It's got a display.
Yeah, so it's smushed together. You can fit a Raspberry Pi. I don't know if there's a photo of it with all of them on. A Raspberry Pi hat, an Arduino Shield, and MicroClick. Oh, and PMod. So not simultaneously.
Quick.
Yeah, quick as well. Yeah, two quick ports. So it was like,
put all the things on there.
All the things. Because what happened is, like, we're looking at different sensors, right, that people might want to use, and it's like, well, there's a really nice Arduino Shield that does whatever it was, CAN or something.
Yeah,
it's like, but there's a really nice Raspberry Pi hat that has all the RGB LEDs. So yeah.
Right.
So yeah, you can make them kind of work. Like, it's a little bit funky, the headers, but
yeah, like the really tall headers or something.
Yeah, exactly. Like the you'll see the hat has like super high headers, and the Arduino is really low headers. So
yeah,
it'll fit over mostly. But yeah.
So then it's got a FPGA. It's got a Arctic 7 on there. Looks like, and that's where it's running the actual like Verilog that is the Sonata, not Sonata, the Chariot.
Yeah. So the Sonata core basically. So
I guess Chariot is the RTOS, and then the
Chariot's the it gets worse. So Ibex is the core. Ibex is this RISC-V core that Low Risk developed. So it's used in a few things. It's used in OpenTitan as well. So Chariot's the extensions that give you the memory. I want to say memory safety, but compartmentalization, all the other features. So it runs kind of the idea of the board is that you can ignore the fact it's an FPGA. So there's a pre-built microcontroller that has an RTOS, and if you really want, you can go and change it. But I think what I've sort of seen is that, especially with students and engineers that just want to develop something, it's like, great, step one, install 20 gigs of Avado. Nobody likes that.
Yeah. Yep.
Right. So it's like step one, download a bitstream and just drag that on, and you're done.
Right. And now you presto changeo, you are a microcontroller of sorts.
Exactly right. And you've got an RTOS, and it's already got the HAL that has all the things set up for the bitstream.
I have been really pleasantly surprised when I personally, like the way I operate with microcontrollers these days, I couldn't tell the difference between a RISC-V and a ARM core if I, aside from like maybe if I'm looking in and seeing what build systems being called, like those usually have a different like RISC-V or the ARM whatever. But like otherwise, I'm like, okay, the tools are there. I don't have to care.
Yeah, no, sure. I mean, I recently started using some of the ESP32C6, I think. Yeah.
Yeah,
and it just kind of magically works. Like I would never know. I wouldn't have even known, what the core was. So
that's great. That's what I want. I want it to work great. I want it to be open for other people to develop on top of it, so that I can get other fun things in the future. But like, yeah, I'm not building anything else that's custom like that. So like this IBEX core, it's just like it's an off the shelf, effectively from low risk.
Yeah, exactly. So that was an open source core that I think, where did it spin out of? Zurich Research. And see, now I'm forgetting this is where I should have fact checked anything.
It's fine.
It's fine.
Do it in post.
Do it in post, perfect.
Yeah.
They in fact did not do it in post.
But yeah, so so this core was run by them for a bunch of stuff, and then there's a version of it that adds the Chariot stuff on to it. So, but yeah, I mean, it's basically like a RISC-V core that's been used. I think it's been used in a number of like tape outs and other things. So it's a pretty well tested.
So then so like students are using this to try out that compartmentalization, like try and kind of break it open, or what's the thought of, like, what's the reason for this overall board?
Yeah, I mean, really, it's just to get people, get people being able to use the core. So the original idea was students, right? If you had an undergrad class, which is why it sort of had this Arduino, right? All these Shield embedded engineers, I think, would be like, whatever, I don't care about that.
Yeah, I use them all the time, man.
yeah. So that's the thing. It's
what you can buy. So like that's really the whatever's fast.
It is quick. So yeah, but if that was the idea, it's like partially student, so get it academic. The hope was to have lower costs. The FPGAs get expensive, unfortunately. So especially at lower volumes, like it's we're not.
Well, at least you can get them these days, aside from the
that is an amazing thing. Like we could just get them under reasonable 14-week lead times, or sometimes if they're in stock.
Thank you.
Like that. So 1+ year. Hope you have enough. And I think it's like, I think our last quotes are now cancelable or changeable again. It used to be we were submitting like non-cancelable
NCNR.
Like 52+ week lead times. How many FPs?
Right. You will pay us up front, and you will like it, and we may deliver them to you someday.
Right. Yeah, that was the best part. So so it is a lot easier now. That's pretty nice.
Yeah, that's great. Okay.
Yeah, are you involved in much hardware, like production these days, where you're seeing that side of it, or?
No, not enough volume to matter. Obviously, we have other things going on with hardware production down in these United States that you don't have to deal with, which is nice.
We kind of have to, but
right, of course.
Like
your parts are still coming from DigiKey, huh?
And I think we use Mouser as a distributor, but they've been. I mean, they're really both. Everyone's good to deal with. They're doing what they can with what they've got. So
totally.
And so far, and I'm going to jinx myself by saying it on a podcast.
You totally are. You didn't have to finish the sentence. You're already jinxed, just so you know.
Already jinxed. It's already done. Right? Is that for some reason this whole time the CUSMA, right, made in Canada, has been exempt. So because we make everything here, or add enough value, or whatever it is, right? We've always ended up. We've never gone the full outsourcing route, which should have originally, but it's saved us because suddenly we're not. We're actually
Past Colin being intransigent and just wanted to build with a fun pick and place.
Exactly.
Saved your modern day ass,
100%. Because we were totally and the issue was that we were going to have to. They had limited space that was bonded that they wouldn't have to charge the tariffs on, even if we're shipping to Europe. So everyone was going to have to pay because they had to pay on import. So it flows through a Mouser warehouse, but it doesn't get tacked on because the end destination is Canada. Is that kind of the short form of that? No, it's like in our case, because our stuff came from Canada. Like because we were source made in Canada, it was exempt under we were exempt under the old new NAFTA CUSMA system, because that's always been exempt forever until a little while ago. But because of automotive,
is that as a seller? Then is that what you're saying? Is that's why it's exempt? Or
yeah, as a seller too.
I see, as a seller.
Sure.
Okay,
yeah.
got it. Okay,
so yeah, so we kind of lucked out there a little. So we'll see. I'm always worried that's going to change, and we'll see.
But you don't just because just to close the loop on it, because you are building in Canada, when parts flow from like a Malaysian packaging facility through Texas at Mauser to you, or but like originally from a Chinese fab or something like that, for instance, do you get any? Is there any tariffs in that loop or no?
There can be. So that's the issue. Okay. They have some space, and I don't know if they've. The problem is everything changed, so like no one wants to make drastic changes, and then the tariff rules change. But
I'm sure Mauser has been real estate shopping in Canada as well, right? Of like some offloaded site, so that
I don't. Well, that's. I mean, so what they had is they did have bonded areas, right? So it's like you don't pay tariff because it's in the special bonded zone,
right?
And if
it's almost like VAT, like where it's only on the final delivery.
Exactly, right. So but it was a physical, as far as I understood when we were talking to them, it's like a physical zone. It's like this area of the warehouse is chained off, because I think the bonding's a generic like customs thing. It's not specific to any tariff stuff.
Right. I'm just imagining like there's like a metal detector looking thing, and the person walks in, but it has like a little like American flag on their shirt, and then like alarms are going for not allowed,
tariffed. But so anyway, I think like if you had some parts would, some parts wouldn't. It would depend if they could get them in that zone where they didn't have to apply input tariffs as they came in. But and like the thing is, what we're seeing is like boxes and just random stuff too as tariffs that.
I see. Yeah.
It's like the supplier gets boxes from the US or the U line because everyone does. And like there's counter tariffs, and like even I was talking to a metal supplier, and they were saying that, there's out west, a lot of shipping would go through the US because the rail lines were better.
Yeah. Right. So right.
That was their entire distribution chain it crosses Canada, US, Canada.
Well, in case I've made my feelings not known on this is all stupid. This is so stupid. And I will continue to say as much, but sorry you're dealing with that. That sucks. And I'm glad, at least on the selling side, it's less bad, right?
Yeah. So, I mean, I feel bad. The kind of crazy thing, and again, I'm going to like totally jinx myself spilling the beans on this, is that because of that customer stuff, I mean, are the tariffs paused or no? Are they back on now? What's the like Chinese tariffs?
Literally can't pay attention. I mean, I'm very blessed that I don't have to like think about it right now. Okay. But if I pay attention to it, I just get angry and start muttering stupid over again. So yeah.
Yeah. So the amazing thing was that what people should do if they wanted to avoid tariffs under the current system is that you should build your stuff in Canada or Mexico. Yeah. Because you'll import from China, right? No tariffs to either of those places.
Yep.
You do enough transformation in Canada or Mexico that it becomes Canadian or Mexican origin.
Canadian product.
Right. And then it's exempt under the current customer rules. So,
which seems yeah. I talked about it on the show a couple, whenever Dave and I recorded last, like my instinct in all this too, is that like, okay, just assuming there's tariffs, I'm going to go with the cheapest stuff I can get. And guess where I get it from? China. It's like, I'm going to get CH32 V003 parts or equivalent, and then just like develop on that and deal, put all my brain power into the terrible firmware I write, but deal with it and just pay the tariff on top of it. And it's very it's just like unintended consequences abound. That's what it really comes down to.
Yeah. Wow. I mean, sure. Stock market bounces were intended, right? That's another discussion.
Right. Yeah.
Anyway.
Yeah. As I said last time too. Yeah. I just feel bad for friends at DigiKey and Mauser and people that have to deal with all the paperwork.
That's the thing. I mean, when we were talking to Mauser, like amazing credit to them because they were, basically just like do whatever you need to do to get this to work.
We just gotta keep things moving.
I mean, we were kind of worried because the agreements you have with them, we can't say specifically, but you normally have like, okay, if we have price changes, we have to give them notice, right? Because I changed the price, by the way, but they were just like, whatever, like if you need to change it, we'll deal with it, we'll figure it out. Everyone's kind of in this together was the feel, which was at least nice.
Yeah. Well, let's switch to talking about actually making stuff on site. So I think the last time you were on, you were kind of started the experiment, but I don't know how much you had scaled it up, but like you've continued to make stuff locally in Canada. You have some pick and place capabilities at your facility, right? So how's that all been going? I mean, aside from the modern, the modern luck that has been bestowed upon you because of it.
Yeah, I mean that was not intended luck, but pretty good. I mean, so this is
that's why they call it luck, Colin. That's why they call it luck.
Obviously, not intended luck. Yeah, so we do a bit. So we use some outsourcing for PCBAs, especially because that tends to be more efficient. But for a lot of smaller items, and we still have the thing where we have all these target boards that have different chips mounted, right? So it can be difficult to know. We did recently upgrade, so we're using some like small desktop pick and places, and then got a slightly larger like floor pick and place, still pretty small. What was it?
Okay,
I need to look up what it was. What are we on the brand?
Not a Neoden. Are you still running? I remember you had done like some Open PNP experiments as well, right?
I used that a little bit. I was using the Charm High ones. No, it's a Neoden, because Neoden, we had bought it from the US. I think it's the Neoden 9 was the one.
Okay. Yeah.
Yeah. Okay. That's it. So it's a moderately, it has feeders and stuff like that. So it's it's pretty good. I mean, it's kind of what we need, we're not doing tons and tons.
Yeah, you're like high mix, like fast turn. Exactly, I remember like you've saying like, oh, well, we need to be able to kind of turn on a dime, especially shortage times. I think you would maybe had talked about that a little bit, but
yeah. And that's exactly it. And this is kind of like when people are talking about the setup, right? It's a bit tricky because I think purely if you were to just look at what's the cost of building it, like, yeah, you shouldn't build yourself, but many times, especially with shortages, but even outside of that, right, having the capabilities in-house has saved us from being able to rework stuff right on the fly, because we have someone in-house that can really do that. Which if you're outsourcing, there's no way you could afford to have someone idle hoping they need to rework a PCB.
Right. That's the only happens when you like really shout at them, like, you got this wrong and I have the documentation to prove it. And I won't send boards to you anymore.
Which like
we'll rework those.
And I don't know what your experience is, and I this is like, I don't know if you can do polls in this. This is a very low commitment. I'm sorry, I should have researched more. But we've tried to do fast turn, and like it has failed almost every time I've outsourced a fast turn I'm multiple different companies. Like
like what style of like what's a fast turn? I guess in your mind.
Well, I mean, like, so twice now, and a few different companies. I've tried to get this. We were doing this, like, it was pretty high spec board, right? It was like 4 mil trace space BGA, and paid for like 3 or 4 day turn, and I forget, maybe $10,000. Like, it was
that sounds right.
Extremely expensive, right? Like but
it was, I mean, that could get a lot more expensive than that, though.
But I mean, for me, right? You want to use the JLPCB, but it took 4 weeks instead.
Really?
And it was, and it just kept.
What was the failure mode? Was it files? Was it orders? Was it?
I don't know. They never told me. It would go to inspection, and then I was like, I don't know. I don't. It's because the thing is, when I ordered that, at the same time, I ordered a JLPCB board, just because I'm like, I'm gonna, keep a few.
The insurance policy, yeah.
Right. Well, and I thought, I was like, well, the fast turn one's going to come. We're going to test it, and then we'll have more JLPCB ones to build up. Right? Just because, like, then, but we kind of needed the quick, or ideally wanted the quick early test. So, but the JLPCB ones came in, I used that, and we just didn't pay or disputed when the 4
weeks versus 4 days. That's pretty bad.
Yeah, which is crazy. And it's like, that was one of the worst ones, but pretty extreme. How
far away were they? Could you have gone to like shout at them in person? I mean, like,
I mean, they're in the US, right? This is all. I don't think Canada had the spec we needed, so it was like, I don't know if I should stay because there's not that many.
No, that's fine. We don't have to name and shame here this time. But maybe if it happens again, how about in 5 years if you've tried it again?
Yeah, exactly. Like I don't know. At the end it was fine. There was no charges, so things happen, right? Like, I mean, that's the problem with entities. It's like, was it someone they hired that didn't work out? Was it shipping error? There was a shipping error on top of one of those, and right. So it's
like we balk at the cost of $10K whatever, but like, what a terrible business to be in. Like, it's just. It sucks. Like, manufacturing's tough if you control every aspect that you can. and it still sucks. And it's like, then if you're doing it for other people and there's, like things happen, right? Like you said. So
yeah, and totally. And that's like, another thing recently we did, where getting some metal parts fabbed, and like first batch was awesome. And the second batch, there's just shipping error. And it was a bit of a rush thing too. Right. And it's like,
yeah.
It's a shipping thing. Like, that can happen. Packages disappear. Things get smashed.
Sure do. Yep.
And like, I'm
currently on day 6 of waiting for a 2-day delivery from DigiKey. It's not DigiKey. It's UPS's fault. It's not DigiKey's fault.
Yeah.
It's just like, okay, well, what am I going to do? It's like, it's in the ether until it shows up on my doorstep. It's like, oh, I guess I could pretend I could talk to someone at UPS. Like, no.
Yep.
Somewhere in rural North Carolina. Okay.
Yeah.
Yeah. Well, so I one of the key things that I remember talking about with the on-site manufacturing too is that like you kind of were hands-on with it at the time and you were like really into it, but maybe you've handed it off for the everyday operations, or are you still doing?
And I forget when exactly we talked before who was with us, but we had someone now, so we had kind of a, basically doing everything production. She's running, combination of running stuff, but doing, things need tweaking, actually doing soldering stuff and anything like that as well. So that's been key. Again, having that in-house and with me stepping away though, someone else is taking on a lot more of the day-to-day, looking at designs, looking at,
cool.
Overview of what are the lead times looking like? What's the current status of all
right, like sourcing and the Kanban boards and stuff like that.
Yeah. So that's the dream. I mean, we're still, to be honest, it took a while, like a shockingly long time after all of the COVID things for us to like. It was only this year that or maybe end of last year that I'd say we were caught up and like.
Really?
Kind of running, back. Which, part of that is just because we're pretty small. So
sure,
there's so many projects that sort of got just, pushed aside because like, well, we're not going to get chips, so let's not worry about that.
Yeah. And then when you're selling this stuff too, I mean, like you're selling to a wide variety of folks as well, right? I mean, like you're selling stuff to other test houses and students and things like that, right? I mean, like you guys have a pretty broad portfolio.
Yeah, exactly. So we're selling, and that's always been the goal is, we want to have students doing research. On the other side, we want engineers using this professionally. We want people doing this as part of security evaluations. So it does range, the goal has always been to have this range of, and it's gone up over time, right? But like $100 to 10,000 or something like that for products that people could buy.
Chip Whisperer is still being made. Chip Shouter is still being made. That's, I guess, what you were talking. I think the last time you were on here was when Chip Shouter. That's the one that's high voltage, right?
Yeah. Oh, yeah. Okay. So it was a little while ago.
It's 21.
So that's still been good. That's I guess time happens.
It sure does. And marches on, man.
Yeah.
Let's see. Wait,
look at that. Wait,
when was it in August of 21? So I had a baby in the house, my first baby. Yeah,
and I saw ARM PSA was on the list, so we're repeating some stuff. People are.
We are. All right.
Yeah, you asked the same question.
It's probably a full recap of what it was. Yeah. But you know what? I was underslept then. I'm underslept now. Whatever.
Perfect.
So I could. What I could do is just read off the notes from the last time. Shout out to good notes, right?
Yeah. Good job. That was not me, so that was all you.
Yeah.
Yeah.
Okay. One thing that I did want to bring up on, so you had mentioned some of the parts you're working on. I found your old post about Apple AirTag teardowns. I was using this as a reference point for the little board I've been building, and I was wondering if you'd been doing anything with this in the meantime, the AirTag and stuff like that.
No, I haven't looked at the AirTag. So I mean, quasi unrelated, not a security side, but just for my own, interest, product development, had been looking a little more back at the Bluetooth tracker system and how that works. But, I haven't looked into all of what the more recent trackers or any of them are using.
I mean, I think this is the main one in the market, right? It's not like there's not like, oh, the new Samsung one just dropped and I'm standing in line to get it. It's like, no, not a solved problem, but this is a very commercially available and accepted solution.
I think it is. Yeah, it is good. I mean, so I use Android. I don't have an iPhone, and I wanted a tracker for some stuff, and I bought Tile. It's fine, but there's
exactly.
so few people on the network. I was testing where it's going to be discovered. Yep. I'm basically gonna have to drive around if I lose it and hope I close enough.
See, this is now you can get into drones, get a new thing, have a little scanner yourself, whatever. Yeah. Network effects are really powerful. It's an important thing to have. So
totally. So that's a big part of it.
It's definitely some cool little hardware too.
Yeah, it is amazing how much they packed in.
Yeah. Cool. So what you mentioned more espressive stuff as well. So what are you doing with espressive these days? I guess that's the other thing. We were talking about the security wise, the HCI.
Oh yeah, right. Okay,
quote unquote hack that was happening. It wasn't really a hack though. It was undocumented HCI, right?
Yeah, exactly. So I mean, and that was and this was I guess I forget if I meant to bring it up with the chariot. The interesting thing right about this is this is a cool example for compartmentalization, right? Even if there wasn't a hack, but it's espressive, NRF, you have these sort of binary blobs that you're linking in. And so if there's security threats in them, and they're going to be a big target, everyone's going to want to find a attack, right, for one of those stacks, because then it applies to everything. So,
I mean, when this came out, I remember all the things were this chip is in, it was for the original ESP32, and it was this chip is in millions of consumer devices, and now they're vulnerable to Bluetooth, over the air attacks. And it's just well, maybe.
Yeah, exactly, right.
Gonna get out of my daughter's Tony box, oh no. Which that is not the point for security. I get it. So
well, and that was the thing, right? So you can compartmentalize it, and that would be really good. But I mean, an interesting thing there, right, is one of the things when I've talked to people before, and I don't have a good solution for this, is for security, how many people want to have very dramatized headlines. And so it's a bit tricky. I was looking at some access control systems a few years ago, and some of the stuff I probably will publish it eventually. I never did because I felt bad, because it was I was looking at one system and it was no better or worse than any other system, right? But if I publish it, I was guaranteed, just knowing the industry, that the other vendors would use that to be oh, look, we're so good because these other people got, had this. But it's no, that wasn't the point. The point was it. So
see, what you got to do is start a TikTok channel and then publish your work and then get sponsored by the other ones and be Colin approves door locks 44, click. I don't know. Yeah.
This is the one that it is.
Yeah. And when you say security system, that's door locks and things like it, or something more.
Yeah, more like access control. The card we're installing. I was installing one at our building actually. Yeah, card reader stuff. So they use lots of it, and generally, I think most people know the older ones had no security, but a lot of them would have keys in the readers and stuff like that. That are
really wow.
Yeah, right. And it's kind of for the threat model. It's not amazing. It's better than the old ones. I think newer ones now have secure elements. So also at the time, the company was coming out with a newer reader that had a secure element that basically would solve the problem. But it got delayed because this was over COVID time. So again, I kind of felt bad because I was they were trying to solve it, but I think it came out finally. So I kind of lost interest.
So what I'm hearing here, Colin, is you've lost your killer instinct as the black hat hacker that we all think you are. Now you're just a teddy bear.
I've gone soft. Basically,
that's what it is. Yeah, age. Soup. Soup is the thing. Yeah, I like soup.
Just want to hang out. Yeah. I mean, I am the one thing I worked on. So my other COVID project too was I started writing down a lot of this, production. Basically, trying to write a book on production, small scale production.
Yeah, we mentioned that before the show. We were texting about that, and I totally forgot about it. So good. I'm glad you brought that up.
A little self-promotion, but I mean, there's nothing to promote because I don't have it's not out yet.
We're going to have hopefully a landing page in the show notes that people can go and sign up to learn more directly from Colin. So what are you going to write about though? So how to do, you said production?
Yeah, small scale. So I mean, really, and I was a bit careful with how I scoped it again, because there's a lot of people have done this. Once you start, you think you're really smart and you've done a good job, right? And then you start talking to other people and realize that oh man, other people are way smarter and did a better job. but it's too late. I made my choices.
Pen has been put to paper.
Exactly. So, so it's really it's a combination of my own experiences, right? It's like a memoir on small scale production. But the idea was to cover everything, right? Because, we've gone to Embedded World and booked booths and like, okay, how do you book a booth? You've got to rent all this super expensive furniture at stupid prices. Okay. How do you do that? So it was kind of like to take people from, I've got a cool idea. And then even if you're not going to, make a product, what does that process actually look like? Right? Like how much work is in idea to, I can ship a box to a person.
Yeah. That's actually that should be like required reading before any Kickstarter or crowd supply campaign kicks off. Be like, well, you have to go through Colin's checklist and add up all your time and
see if you really want to do it. Right? Was like in doing it because I didn't do that. I would just like started being like, I can make some PCBs. Let's do it. Let's do a Kickstarter. How hard could this
possibly be?
Right. This is back when Kickstarter didn't really enforce anything, so you could just do it.
Yeah.
So it's a bit of like lessons learned over that.
Yeah. Do you think a lot of it will change appreciably in the next 10 years as well? I mean, that's the other thing is like some stuff has changed from 10 years ago, but
Yeah. Well, so the problem is I started this over COVID, right? So it's now 5 years old. So I've had to go through an update. It's about 70% plus written. So it's actually pretty far.
What I'm hearing here is that you have a future upgrade path for your book as well, right? You can have like a 26th edition. Colin has to update. The Neoden 14 just came out, and that's a better one.
Yeah, exactly. Yeah, right. Yeah. Well, yeah. So that'll be one of the things to add, I guess. But I mean, I'm trying to. A lot of it's super stuff that hasn't changed in 30 years, right? Is kind of the goal.
Right.
Even simple, what I would call simple, but people don't think about, right? Like, how do you deal with inventory from an accounting perspective?
Right.
There's a lot of stuff that you can get some really basic examples, but I just struggled to find good examples specific to electronics hardware.
And you don't think that would be regionally specific either, Canada versus US, in terms of like, I guess taxation is, you have to consider it at some point
exactly,
as well. Just think about this and go talk to a professional. That's good advice on its own, I guess. Right?
Yeah, and that's basically it. It's like a lot of it is, because a lot of it will change and, I've tried to include details where I can, but a lot of it is just like, here's something. Again, things people don't, I don't know. I don't think some people think about, sometimes you just don't have time to think about it. So at least if you knew up front, right, you could say, okay, I need to make sure I talk to, someone about how I'm going to deal with all this inventory that's coming in. And, I remember
that's true. Even when to go talk to a professional, like, so you're not showing up at like an accountant's office and they're like, there's nothing here for me to do. Right. Like having like that kind of like path and guide is very useful actually.
Yeah. Well, no, exactly. Right. And that's like, I don't know if there's still stories of this, but I remember from early Kickstarter, there'd be a number of times when people would get the Kickstarter money, right? But they wouldn't have the expenses yet because they didn't realize that, if you just buy the parts, it doesn't actually count until you ship it, right? Like you can't realize the cost. And so they screwed themselves because, they needed to defer it or stuff like that. And like they didn't do it in time. And they basically on paper had a super profitable business because they had all the input money and they didn't have expenses yet.
Yeah, right.
Right. Like they hadn't set it up well enough that they could amend their return or stuff like that.
Right. Yeah. So like Kickstarter money gets delivered December 31st and all the parts are purchased on January 1st or something like that.
Yeah. Stuff like that. Right. and even in that case, like depending on what you're using, you may not even be able to call it an expense until you ship stuff out because it's like, it's just an asset, right? Like now you have an asset of right. Like we have 100K.
Yeah, it's inventory. You have to get taxed on that, at least in the US. I mean,
well, yeah, exactly. That's it, right? So like you had 100K of profit and then you spent 100K, so you have zero cash. But on the accounting perspective, right, you had all profit and asset. Like, right? You had no expense. You had zero.
Yeah.
So that's stuff like that, right? That like, when I've been talking to people starting this stuff, it's not crazy, but I also think it's easy to miss if you're just coming out of school, like was sort of the thought process. You've got a good idea.
That is one thing I wanted to ask you about too, since you are a teacher and you're dealing with the youths, and we were talking about like their use of AI and kind of generally just students, kids these days as a general stroke. What trends are you seeing there?
Yeah. I mean, it's interesting. There's tons of ChatGPT, like, and actually what was terrible, I don't know how much readers are plugged into it, but they released, a few months ago, what was called deep research mode.
Deep research. Yeah.
Totally. Where it would like give you citations and everything, which is terrible timing because in the class, I was just teaching a class, in the winter, so like January to April term. And I had a big research paper as one of the assignments because I was like, oh, that's something that ChatGPT doesn't do a great job on. But it's like, boom, they released the exact thing that. But yeah, so the thing is, I mean, it's kind of an existential question of, are we asking students to do things that will be automated? So is it a stupid thing to ask them to do? Right?
Got it.
Am I asking them to do manual multiplication when everyone's going to use a calculator?
Right. Right.
So, and it's kind of how I'm trying to approach it in ways of making new questions. I mean, one of the assignments actually I have them do, so that in this course they were, I was covering for someone. So it's like they're using ROS2 to make a robot do various tasks.
Oh, that's kind of cool. Yeah.
Yeah. So, I mean, I learned a lot doing it. Had to pretend I knew ROS2. But yeah, so I have them ask ChatGPT to make ROS2 code to drive the robot in a square, which it does an awesome job at, right? Because there's a million tutorials doing that.
Got it.
I then say, okay, use the same prompt and ask it to drive in like a maple leaf. And it just...
so Canadian. Come on, man.
I had to tie that in somewhere. It had to be something. That there wouldn't be tutorials about. But it explodes. Like, it does not work. It doesn't even come close to working.
Oh, I bet, yeah.
Right? And the point is, it's like, it is a good tool. You could ask ChatGPT, get me the vector of a maple leaf. Like, you could get it there, right? You could say, make a function that drives the robot to an XY location, and it'll make that, and that'll work because there's lots of examples, right? Like, you could tie it together. So it's kind of to prove, because like what I was seeing is students would just like put everything in, and it either worked or didn't work.
Right. And then they try it again.
Yeah,
right?
like there is it was teaching them how to be like, okay, make small testable things, right? Mm-hmm. Like it is a tool that's useful, but make sure it's testable. You're responsible for what it's doing. So
I saw an article that was about like basically the skills of the future are one of the skills of the past, which is just troubleshooting, like being able to troubleshoot. There is going to be you have to assume there's some AI slop in the mix somewhere, fine, whatever, but you still need to be able to figure out what's going right, what's going wrong, how to test your assumptions, like just getting better at that. If you were only teaching that, like troubleshooting, I feel like that's all every course would have been useful for that sort of thing,
Yeah, absolutely. And that was an interesting ChatGPT usage I saw actually is, we had some sample code that we're giving them that, another prof wrote. So like, it doesn't exist per se, right? Like he made it really specific for whatever interface, and there'd be errors, and like the errors would come up, and they were putting those errors into ChatGPT, which of course it's not going to work because like they were not generic error messages. Like it was just, this is an error message for, right. But that was still the first thing was like, do that.
Yeah. Does that mean there's more like when there's like like a testing kind of paradigm then as well? Education always has like some kind of certification testing, whatever. Does it mean that everything has to be kind of in person, even if there is like an allowed AI agent that's maybe with them in it? Like, but it's just like on site, you're watching the assessment happen.
Yeah. I don't know. I mean, it's a good question. That's stuff like that. I don't know if, at least in our university, I haven't seen good answers to it yet, how they're going to deal with that. I mean, I was using a lot. So for this class, they just had a final project. So like, they had to make a functioning robot that did various things. If they used AI to generate code, I didn't really check. I kind of, to some degree, allowed it because I said, if you can get it to work, right? Like that's up to you how you generate the code. But yeah, so for pure tests, like the thing I think we're getting at, right, is like asking students to write a research paper on some basic topic is like there's no way you could do that.
You're saying, they just don't do that anymore. Yeah.
Like, well, people still do, but I just think you're totally like, some students are honest and not using ChatGPT, but like they're probably at a disadvantage. Because like, and it's so hard, they're trying to use tools to detect AI, but I don't really trust them that much. My reliability is low. So like you're accusing students that haven't, right, of using it and letting others through. So
I just feel like the problem is always the schools are there to test and certify and whatever, right? And like that's a huge part of the educational process to like say that you're okay to move on, but like the actual focus on learning, like that's always the tough thing of like they're often decoupled. They've been decoupled for years and years anyways, right? Even say for all of education, of just like, just because I test on something doesn't mean I've actually learned it. If anything, like if it just blew up the testing process and it was just focusing on the learning process, that would ultimately be a good thing, but I don't know if it ever would go that direction, you know?
Yeah. No, you're totally right. Like that's, I mean, there's been some discussions. I know other universities have looked at this about like, what is the value of marks per se? Because as soon as you have marks, then testing and then becoming like, did you get 87% or 85%? Right. Is a thing. And then it's, which then really is like, okay, what's the rubric for the assignment? Because I have to exactly hit that. Right. Because I need to maximize my marks because that's going to in the future impact a scholarship or something.
Right. Yeah. Ties back to money and, like how people are there and what they're like it's a service industry. You're here to like administer a service and, certify based on this so that, all that stuff. Yeah. So it does ripple far out, but someone should still be saying, are the kids actually learning anything? Like, am I learning anything? Like, do I learn anything when I, use an AI engine? Like, maybe glancing, but like, do I need depth of knowledge for situations where I'm not going to have access to that stuff? Like, I don't know. It just, the changing nature of like the second brain, kind of the offloaded to an AI sort of thing. Like, I don't know.
Yeah, not very much. I mean, my excellent, this is getting very existential now. I'm sorry.
Sure. Yeah.
But it's like, right. Are we getting to a stage where you'll have like knowledge will kind of level off in a way because, if everyone's just asking ChatGPT, like who's posting blog posts and who's posting, Stack Overflow questions and stuff like that. Right. So it's like, if AI doesn't know the answer, then
there's no novel discovery and like publishing about it. Like, what does it ingest?
Yeah, exactly. Right. Like where does it, if people aren't publishing as many things because they're not, just writing Stack Overflow questions and stuff like that.
Yeah. Right.
Like they're just asking ChatGPT and that doesn't become public. Maybe it trains on it. And
that would be the most old man thing for us to do is like soup. And then like, hey, do you remember the good times? Stack Overflow, man.
Yeah, back in the day. Or slash people yelling at you.
Back in my day, people were grumpy about things and the AIs learned from it.
Yeah. So I don't know. I mean, it is bit for research, right? That's where like AI, and again, that's what I'm trying to show. Like, hey, it's good for basic stuff, and it could be good for more complex things, but
sure. Yeah.
If you want to push the boundary, then you can't ask it to push the boundary because it doesn't know. Like, it's, and I think just removing the magic is almost what they need because for some students, I feel like they do, right, really be like, I can ask this anything and it gives a good answer.
Yeah. Everybody learns that the hard way like a couple times before they're like, oh, maybe I should think about this and be strategic.
Yeah, exactly. Right. Which, and the problem I see is, right, that if you're teaching a class, like, I don't know how many classes you've seen where it's like, this is the same material from the last 30 years, right? And like, so of course it's giving a great answer for every class question because
right.
It's not novel.
Yeah, I guess some of it is the onus kind of goes back on the professor to put more input in for novel questions, for novel solutions, that sort of thing. But yeah,
exactly. Which is, and I think that's kind of what we're getting at, right? Is, which I don't think is a bad thing. Like, when I went through university, there wasn't ChatGPT, but there was people that had, burned CDRs of a whole bunch of scanned assignments from like, 10 years. And they would be like, here's all the assignments. There is an
old sentence. Burned CDRs of old assignments.
Yeah. Right. But I mean, it's to some degree the same, like cheating's always there. Like, yes, it's
sure. Yeah.
More effort.
And at the end of the day, those people also did not learn those things. Right. I mean, that's same, right? It's like, not like the person who, just formulaically, use the old assignments to, fill in the blanks and get the output. It's like they got the grade, but they didn't get the knowledge. And then like, okay, but we need the knowledge. We still need people who know things, right?
Yeah, well, exactly. And that's kind of what I get at when people, because some profs will really be like, ChatGPT's, ruined everything. I think it's always been ruined in a similar way. Like it's, if you're realistic, maybe it's more obvious now. Like
these kids are using abacuses, and that makes the math easier.
Yeah.
Yeah. Well, I mean, are you, you interact with students and stuff like that too. Does it make you more hopeful though that they have access to more knowledge? Is it more novel solutions for things as well?
Yeah, I mean, I definitely see, especially, I mean, this course was interesting because it was sort of a new topic for me because it was this sort of cover. So, there was like a few groups like, oh, like I made this whole simulator for my robot. And it's like, oh, wow, I didn't even know.
That's wild.
I don't know how to do that because this isn't stuff I do a lot, so there are still, when I went through, I remember it being like, there's a few really super engaged students who want to do all the things. So it still seemed that way. Like there was some very engaged students. And I think, they were doing way, like they were 3D printing tons of stuff. And a lot of people were doing that. But, looking at PCB designs, they were doing quite advanced coding.
That's awesome. Yeah, that's the thing. Like it is like it opens up new spaces and things, barriers have come down. That's really great, I feel like. And I guess my experience with that is just like, being in the hardware industry, interact with, younger people that are coming in that are like more software savvy too. And just like software methodology brought into the hardware space, like that has been very positive as a general development, kind of across the board. It's chip vendors can't get away with the same kind of stuff that they might have put out. But then they also hire smart people to build software, and that it's just kind of like rising tide sort of thing, lifts all boats, which is good.
Not very much so.
Yeah. Like if I started on ROS 2 right now, I wouldn't know where to start. So like if there's a bunch of beginner content that like everybody can start with, and that helps me too when I go into a new topic area. So
no, exactly right. That's the thing. There was tons of material out there, and like, like this is, and the discussion in this course, and we keep having this discussion in various courses is, where do you start? Because I think there's only so much time, there's only so much you're going to cover.
Yeah, right.
So it's like, do you start at like, we're still doing resistor networks and stuff, which is important, but also you then don't have time for.
Yeah. I haven't run into many resistor networks myself in.
Well, exactly. That's it. So like but the argument is it's like, well, this is used in, heat flow, and there's a bunch of stuff where it's used.
Yeah. Right.
Which isn't wrong, but also.
Right. I sometimes I feel like it comes down to like practical versus academic, like end goal as well. So like if someone's going to be like going to get a PhD in like some thermodynamic field, then they probably need to know that sort of thing. But like me as like, a dummy dumb engineer who's just going to build things and like hopefully they work, it's just a different outcome that I'm hoping for. Like I never wanted to know all the base physics about things. It's like I just wanted to know enough about them to move on and like make a thing, So education. Well, you got yourself into quite a space there, Dr. O'Flynn.
Yeah, that's it's something. But I mean, it is I think it's interesting to see what people are coming up with. Like it is amazing, what the capabilities are, and lots of people using, little Linux things and stuff like that.
Yeah. Yes. Yeah. It's there's starting from cool spots and doing cool things. That's great.
Yeah. All
right. If people want to see the cool things that you're working on, Colin, where can they find your work?
So right now I have a half updated blog at colinoflynn.com. That's probably the best spot. Okay. Yeah, I'm trying to post more. So I recently recorded a video. So for this class, actually, a kind of, I called an intro to PCB video series, but again, tons of caveats because it was designed to be shoved within like one or two classes. So, there's only so much you could do in there. But yeah, my goal is to get more content posted. A few more teardowns too. So one of the things I was looking at was some RF stuff. So like a marine X-band radar, looking at how that works. And a few new topics, right? I mean, one of the fun things about academia is you have so much crossover. So I'm trying to embrace that a little more than just pure security stuff like that.
More fun things coming from Colin then as well. And we'll, you'll be back in 5 years. We'll talk about it then and
see how it is.
Soup and, see how it goes.
See how life is. ChatGPT. Yeah. Maybe it'll just do the interview for us, actually.
Yeah, exactly. Yeah, exactly. Notebook
on. Enough content.
Yeah, exactly.
Schedule it now.
All right. Well, thanks for being here, Colin. Good chat.
Thanks so much for having me, Chris.